Hello everyone, I'm Charles from Industrial Vibration Systems. In this video I'm going to be demonstrating our new Expert software for noise and vibration data acquisition and analysis. Now this software works with hardware from a couple of different brands, including Data Translation, NI and Vertons. And today I'm going to be demonstrating it with this very simple rig that I've put together. I want to use 5 channels, so I've chosen the slightly larger National Instruments kit. And the 5 channels are 1 in red, 2 in yellow, 3 in green, they're all vertical. Channel 4 in blue, we'll call that horizontal. Channel 5 in black, we'll call that axial. And you can see the same channels plugged in here. Now you can see the software open in the background. That's all the default settings that you get when you open the software up. And by default it's turned all 8 channels on and set them to IEPE mode. So I'll just turn off the last 3 channels because we're not going to use them. Okay, and we'll also stick with the default sample rate, which is the minimum for this hardware, which is about a bit under 2 kilohertz, and that's more than enough for this because we're only looking at low frequencies. So I'll just go over to the plot settings. By default the time waveform for acceleration is turned on. I also want to plot spectra for acceleration, and I'll change the y-axis scaling on the spectra to 0.1 millimeters a second. And I know that's what I need because I've done a trial run with this. By default we've got peak hold and current FFT on. And because we're going to be looking at 10 plots, I'll change it to 2 columns of plots. And if you go over to the plots tab, we're not logging yet, but I'll just show you the layout of those plots. So we've got the time waveforms down the left and the spectra on the right. And this is just a little bit of text explaining to you what each plot is. So we'll go over here and we'll start logging. So I'm expecting, because this is effectively a rigid body mounted on soft springs, I'm expecting 6 clear natural frequencies at fairly low frequency. So we've got the x-axis scaling on the spectra going up to 20 Hertz. Okay, so I'll start with a vertical impact. Now channel 1, 2 and 3 are vertical, which is why we're getting a clear signal on those first three channels there. And that strong frequency there would be the main bounce mode. So I'll do 2 horizontal impacts just to make it easier to do the analysis later on. 1 in the middle, and channel 4 is horizontal, so we can see that picking up here. And I'll also do a horizontal impact on the outer edge there, just to identify the twist mode. You can see it'll pick up at a different frequency here. That one there is probably the twist mode. And last but not least, I'll do an axial impact. So channel 5 is axial, so we expect it to pick up now. And you'll expect this low frequency mode to show up there. Okay, and as you can see, the thick line is the peak hold spectrum, and the thin line which goes up and down after I do an impact test is a current spectrum. So having that peak hold plot just makes it very simple for you when you're doing these impact tests, because you can do impacts in a couple of different directions, come back and look at the screen and see all the natural frequencies you've got. So I'll just stop it logging now, and I'll put together a second video just doing the analysis and just use a screen capture for that.